Yo, 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 good morning everybody. What's up, Ayland? I guess it's not morning where you're at, though, but is it in the middle of the night? Anyway, I'm back this week and we're gonna continue with the water system for this game. For the past couple of weeks, I haven't been able to stream or work on it much, but the plan is to step it up this week. I haven't looked at it since I stopped my stream on Friday, so we're just gonna jump in right where we left off. It's 3 a.m. Yeah, I remembered. So we have a very naive recursive implementation of the water system here, and it's also binary. And by binary, I mean we just fill a voxel or a pixel, or we don't. We fill all pixels with the same amount, and that amount is calculated by the initial raw height and fluid amount we add to the initial pixel. So basically, we calculate a new terrain fluid surface height, and then the idea is to disperse this one over an area, basically. So we go to neighboring pixels, check if this and this holds true. If so, we fill it, and then we move to their neighbors. So moving outwards pixel by pixel, i.e. all pixels will at least be visited 8 times, so once per neighbor. Could probably have an edge case or two where we revisit multiple times, but hopefully as we go along and complicates this fluid solver, we might figure out a way to simplify it, or to remove or to fix those edge cases. Handle them might be the correct term. So yeah, this one is pretty damn straightforward, and we got it working somewhat last Friday. The problem was that it never terminated. Luckily, we implemented it as a coroutine in MonoBehavior, so we could, when we noticed that one iteration of it took too long, we could just exit. And we know why as well, or most likely. So what we do in this method is, so currently we talk a lot, or we utilize float values that are packed into a texture, and we utilize float values that we define here. And the way we store them in texture is probably having we're getting a precision problem from that. So this check here, when we check a neighbor pixel and we check that neighboring pixel's fluid surface height, if that surface height is less than fluid surface height, which is the one we're gonna spread to all pixels, then we do this. Otherwise, we don't. So basically, it's a check to see, with the current implementation, have we already filled this neighboring pixel? If so, don't fill it again. But even though these are supposed to be the same value, they are not, because of floating point precision. So what we're gonna have to do here is to introduce a error margin, and then we're gonna do a comparison with a approximation instead. Could probably use this one, so that's what we're gonna use. What's up, Cooler SK? It's water now. It's water these days, I promise. Aelund, I sent a message in your Discord. Nice. We'll check it after the stream. Good morning, Geralt. Hope you had a wonderful weekend. Hope you all had a wonderful weekend, by the way. So, let's just double check this one. See how we can use it. Approximately. Is that what we do? Okay, true if they are similar. Yeah. I mean, are we going to see to get sea monkeys in the water? Let's see here. Good morning, by the way, or good afternoon. What the hell are sea monkeys? Never. Marketing term for brine shrimp. We might not see exactly sea monkeys, but probably something inspired by. It's always about the grass. On some levels it is, I guess. Nobody really knows what a sea monkey is, but that's the beauty of it. Okay, I'm intrigued. Okay, so what do we have here? Okay, we have approximately, but that's not exactly what we want to use, so we're probably just gonna go with a custom solution that is something like, and we also have a different ways we can introduce this error margin. We could send it in here and here, or we could add it to this one. And since we're like Fluid Solver is inheriting from on a behavior right now, only because we wanted to use coroutines. Eventually we will not have this as a mono behavior, I don't think. To protect the grass from the flame. That's true. Like, when it comes to flames and burning grass, I haven't really thought about it, but we're probably not gonna support fire. Feels a bit too stressful, you know. And what's up, Lemnine, by the way? Closest I will get to touching grass at least. So at this point, we're just gonna do this. And I'm gonna call it fluid surface height error margin. And we're gonna do fluid surface height plus this one. It's gonna be... I don't like setting it manually, so I would love to be able to calculate it from get float precision supported texture 2D Unity. That is true. Let's see here. Terrain data. And we're using RGB A32. Is that 8888? Floating point precision 8-bit. And we're using linear as well, so it should be okay. Mini float. Yeah, exactly. Cooler SK. Quote, cozy creature collecting game, unquote. And then, should we make the grass catch on fire? Or is that too stressful? Yep. The true way to get closest to touching the grass is VR these days. And Neuralink is probably up there. I've been following the guy that... Was it the first human ever that got a Neuralink chip in his brain? Which made it possible for him to play Civilization. That was very cool. What precision do we have? Or what error? Do we have error? Is this the error margin we should have? I don't know. I don't know how that guy's lawyers sleep at night. Honestly, I don't think they sleep at all. A 0.02 should be enough. UDev, what's up? You should check if C# has 8-bit float at all. I don't think that's relevant. Like, what's relevant is how we store the data in the texture, and there we store it as 8-bit floats, right? 8, 8, 8, 8, 32 in total, so 8 per channel. And that is where we get our floats from. And if we work on, what is the default in C# Unity float? Is it 32 or 16, right? So if we read a 8-bit float and put it into a 16-bit float, we should not be getting any issues, right? Oh, float is 32. Oh, that's nice. Okay, so we put a float 8 into a float 32. Should be no problems at all. Like, what it all comes down to is us not having to define this manually. Like, if we could get the possible error margin from the texture format, we could just add that one here and it should be okay. That's just one nice little... The less values we have to put in manually, the better, I would say. Fluid Solver 0.02. I said before I put in a value manually, but yeah. Oh yeah, so when we read the value, when we do get pixel or value here, we do get pixel, and this one returns a color, and then we just take out one of the channels of it. So, like, I'm just trying to follow what's happening behind the scenes. When we actually use it on the CPU, it's not a float 8-bit anymore. As soon as we read it, we get a float. So a float 32. So as soon as we do this, we get a float 32. But like in texture memory, it's actually 8-bit, I think. Okay, we have an error margin of 0.02. That should be okay. And now we should be able to add our water, see it spread, and hopefully stop in time before Unity crashes. And what did we add? 0.1. And we still... With amount, old value was, new value is. Okay, so still too small of an error margin. What the hell? Filling position with amount minus. Ooh, we might want to check into that as well. We don't want to fill with negative values. Although I'm very interested in... I thought we had a bigger than 0 check, but probably not. You can just add permanent indent in your terrain for testing instead of creating it again and again. We could probably, or we should probably do that, yes. But then we're moving into permanence, and haven't really implemented that yet. Or actually, I think we have one method for it, ish, but not fully implemented. Okay, filling an amount with minus values, that's not good. And so if so we get this one as 0. Ayland, you know the last project I tell you I'm working on. The last project you told me about was a game, right? But the last project you worked on, as far as I know, was the console utility. Okay, so the problem we get is that this fluid amount is minus, so that means that this one is bigger than this one. Interesting. So here we have another, I think it's still error margin issue, because what we get here is this one is the terrain height at this position plus whatever fluid we have at that position. I'm still a little bit bothered that this error margin doesn't help us out more than it did. Oh yeah, that's right, Ayland. Yeah, that's right. Orbiting stuff. Okay, so this I'm a little bit weirded out by this. The fluid amount which we calculate is fluid surface height minus terrain height. We get a negative value here if this one is bigger than this one, right? But this one is terrain height plus some fluid. So if this goes through, how the hell is this one bigger? Yeah, when we have negative values, they are extremely small, so it's just a problem of... oops, did I play? I want to change the... Yeah, we can change it now. I don't want to be too... What am I missing? Raw height plus fluid amount. Oh, yes. Let's see here. That's what we want to do, right? Okay. Yeah, we're gonna have to introduce way more visual stuff to properly check these things, but I think it's pretty much okay here. So if we do this and we do... we add 2. Looks all right. .3. That's fucking great. The biggest problem here is gonna be... I think it's okay. That's beautiful. So the idea then is, so right now this very simple fluid simulation, it calculates water values, very basic. Eventually we want to recreate a mesh out of this later on. So we're probably gonna have to, it's a question of how we store it and how we parse it and so, but the idea is that for each pixel that is water, we take those and then we recreate a mesh out of them. But yeah, when it comes to edge points, so basically we want to recreate this grid. So for these it's pretty simple. We have 1 point here, 1 point here, 1 point here, 1 point here. We can easily create a quad, and we want to do that for all the pixels that are water, but we want to do some additional stuff for edge pixels. So for instance, this one here, we want to connect this one to this point as well. And if we do that the correct way, we will get a mesh that is intersecting very nicely with the terrain around it. I think this is gonna be pretty good. American Taco, what's up? What's up? Elon, well, I added time control. The planets can orbit other planets. A grid system, nice. A better star shader. Damn, you've been productive since last Friday, right? What if you put water on flat ground? Yes, that one we can't handle right now. So if we do it right now, we're going to flood the entire terrain. Eventually we're gonna have to introduce some form of, like, we're gonna have to check if it goes on for X amount of steps, then we just quit. And X amount of steps is going to be based on the initial fluid amount in some way. But we want to be careful because we might have terrain that looks like... let's stress test this a bit. Terraform can do this, and then we do this, and then we do this maybe. What do we get here? Water 4 maybe. Damn, that's fucking beautiful. That is great. So, for instance, if we put it here now, we're gonna fuck it up. Yeah, so we want to add we want to start introducing fluid amounts. Because, like, for instance here, when the fluid disperses from here, we want to add this much water to this hole, but then we have a little bit of a bottleneck here. So the water we add when we move over here and we start adding water here, we pretty much want to add less water here, because given this, less water will make it over the edge into this one, maybe even such a small amount that we won't even get above this one. So yeah, we're gonna have a big pool of water, and we're gonna have an edge where we have some water trickling down to a pool of water with a smaller surface height. And yeah, that goes against like real world fluid how fluid works in real life ish, but that's what we want. Yeah, we're gonna get to that, Ayland. American Taco, what if you have two types of water? One that is for a small area that automatically fills itself, and another for a large area that slowly stops after enough length? Yes, like water having its own mass, we're gonna go. There is a flood in the area indeed, but yeah, when it comes to water having its own mass, that is what we're gonna introduce. But we're gonna introduce it in a non-real world-ish way. Because remember, this fluid simulation, it's not going to be real time. It's going to be running in the background, trying to get to a stable state, and when we get to a stable state, that is when we introduce the meshes, and the stable state might be a fucked up state related to real world physics. Our grass must receive only the finest of the water, indeed. And I remember, like, initially my plan was to not allow for water, not allow for grass underwater, but then I got some extremely nice input, like, and we eventually converged toward having grass underwater being rendered in a different way, so it looks like seaweed, for instance. And I just think that's such a cool idea that is worth repeating. So yeah, I think we have a very simple fluid implementation right now, extremely simple, but it's in such a state that I wanna commit this one before we continue destroying it. So I'm just going to commit this real quick. Let's see, what is the issue number? I'm going to close this one. There we go. 89. And I think this is probably the first commit to this issue. Yes. I wonder how you use compute shader. Yes, we're gonna, like when we have this implemented on the CPU, we're gonna start exploring the possibility of implementing it in a compute shader. Because what it eventually is, or what it is in practice, it's just a number of convolutions. I would say convolutions ish, but they have a structure to them, a order of execution that I'm not entirely sure will translate too well to the architecture of a GPU, but we will find out. I'm not that well versed in compute shaders either. I've only done very few things with it. And now I'm talking like compute shaders as opposed to shaders. But anyway, I'm just gonna grab a cup of tea real quick again, so just give me a couple of seconds and we will continue with this fluid solver. Okay, back, let's see. So what we want to do basically is we don't want to send this one on and on and on again. Instead, let's see here. I'm wondering, do compute shades works with vector 3? Like, depends on what you mean with vector 3. They probably don't work with the Unity vector 3 struct, but I'm pretty sure they have something representing a vector 3. I would guess float 3. And if they don't, which I doubt, we can just introduce our own. So yes, what it all comes down to is this one. We want to limit this one in this first iteration. So it's basically, if we get to, like when we calculate the new fluid surface for a pixel, let's see here, I need to think this through. Let's do some quick drawings. So the idea is that if we would have something like, let's say I'm drawing the terrain height here, and I'm gonna draw it in integers because that's easier to do here, even though we work in floats. So if we have a height of, we have a height of 2, 2, 2, 2, 5, 5, 5. And then we have a height of 3, 3, 2, 2. So If we then add a water amount of 2 here, so let's say 2. What will happen then is that we calculate a new surface height, which is 4. Well, that's a bad color. 4. If we move to this one, we can see that 4 is less than the height here, so we don't fill it up, and the same goes for all of these 5s. And then if we move upwards, it's the same, so we have a neighbor of a surface height of 4. So we send on 2, we get 4. We send on 2, we get 4. We send on 2, we get 4. But then we get to these points, and this is where we're gonna start handling it a little bit different. So from this one to this one, we move 2, but it's a fluid height of 4, so we're gonna have 4 minus 3, which means that instead of having a fluid amount of 2 here, we're gonna have a fluid amount of 1. The same goes for this one, we're gonna have a fluid amount of 1. We can see that the height is the same, but the fluid amount is less. So when we go to the right here, we want to fill it based on fluid amount, which would give this one 1, 1, and we'll get a fluid height of 3. So this edge here is going to make it so that it's less water over here compared to here. That's basically how I want this naive fluid solver to work. You need a few more tabs in your browser. Like, honestly, this isn't that many, is it? You can still see the first words, so that's good. And Aylund, one problem I have, no idea how to write a compute shader. Yeah, I'm sorta in the same boat. And yes, I would recommend doing it. Like, compute shaders are hella interesting. What's up, Tokig? So. What this means is that we want to send onward the fluid amount as opposed to the fluid surface height. And we want to recalculate the fluid amount. Yeah, we want to send on fluid amount and surface height, because we can see here that we get surface height 4. We get a surface amount, or we get a fluid height 2, but we never want, so even though the ground goes up here, we don't want this one to turn into a 5. So we need to send in fluid surface height, and we need to send in fluid amount. That's the first step. So in this recursive method, we're gonna do fluid surface height. I wonder, probably gonna rename this one max fluid surface height, and then we're gonna send in float fluid amount. So let's see here. We get the terrain height, we get terrain fluid surface height. We still want to do this one. Definitely. But then we want to do an additional check. Let's see here. Can I do bool? So if the fluid amount in the terrain pixel is less than the fluid amount we need to add, and then I wonder, we probably want to have one of these as well. Okay, so 2 checks instead of 1. Let's see. So what we want to do here is we want to calculate the new fluid amount for this one, and we don't want to do it from this fluid amount, but fucking hell, can we do without fluid amount? I might be complicating things here. English Sparrow, thank you so much for the follow, appreciate it. We could probably just do with fluid surface height. No, maybe not. Yeah, it's the fluid amount we want to work with. So here we add 2. Here we add 2, but then we notice that it's so we could probably do something like this. Fluid amount, what do we do with this one? With amount, yeah, this one we want to recalculate. Instead we want to do float new fluid amount. Fuck, I want to rename these. Fluid amount, ingoing fluid amount. But we're gonna call it input fluid amount. So yeah, then we can do fluid amount, and we want to calculate it like terrain height new, or actually max fluid surface height minus terrain height, then we get the new fluid surface, but doing only this might yield us a so the fluid amount here, adding this to the terrain might lead to a higher value here. So for instance here we would be getting max fluid surface height is 4, Terrain height is 3, so we actually get 1. Yeah, and that is the fluid amount we want, right? Although I wonder... No, that's exactly what we want to do, right? So in this case it would be 4 minus 2, that's 2, and that's what we want to add. And in this case... yeah, okay. So in this case it would be 1. But then when we move on to this one... I wonder how... What we could do is float new max fluid. Or actually... Yeah, new max fluid surface height is equal to terrain height plus fluid amount. Yeah, I might be doing this in... I might make this more complicated than it actually is. But hey, it's Monday. And this one is the new one max we're gonna send onwards. So... Fuck, do we really need this one? I don't know. And here we set fluid amount instead. Fluid amount, old value was, new value is. And then here, ooh, why don't I remember? What is it? Can we do this? And then we want to go. Okay. Yeah. How fucked would I be if we just press play here? So adding 2 here. New fluid surface height, raw height plus fluid amount. So this one is 4, we send in 2, 4. We get a lot of values. Let's take this one for example. So we get 2, 0, 0. This one is 2, 4. So this one is yeah, this one is 2, and this one is 4. This one is 0, this one is 2. So true on both of these. We move 4 minus 2, we get 2. So then we get 2 plus 2, we get 4 again. And then we just continue. Okay. So what would happen in this case? Input is 2, 4. Both of these are true. This one is 4. This one is 3. So we get 1. This one has terrain height plus fluid amount, and this one is 1, so we get 4 here, right? And then we continue. That's good. I just want to double check if we move from this one to this one. So then we have a fluid amount of 1 and a max surface of 2. What happened? I think my computer mouse died, which is weird. I'm sorry about this. Right in the most exciting part. My mouse died, but it should be loading. I wonder why it's not. The fuck? Let's try this. Okay, one sec, I'm just gonna run AFK real quick. Unfortunately I can't. I'm gonna check if I have some extra mouse, otherwise I'm fucked. One sec. Yo, what's up, Arthev Life? Thank you for the raid, appreciate it. And long time no see indeed. I'm doing pretty good. The project is going good as well. How about your project? The Twitch game, right? Although I'm having a little bit of a problem now because I think my computer mouse just died on me. For good. Possibly. Let's see here. Can I do... What do we have? Oh, we want to go to... Jeez, this is depressing. What's up, Desai? What do we have? Why don't I have these options? Tricky to answer, I kind of burned out. Oh, sorry to hear, sorry to hear. Had to take some time off, been studying computer graphics like a madman. Ooh, that is interesting though. Ah, nice, Ayland. And yeah, good morning, Desai again, I said it. It's pretty much... I'm not having any luck today. Why can't I control the mouse with the keyboard? I fucking wish I had a trackpad right now. Let's do this then. Are you kidding me? Yeah, I do, Ayland, but they are unfortunately not close to me, at least. I should be able to control Well, that's not what I want to do. Ooh, something happened. Let's see. There we go. Okay, beautiful. I think we can continue this. I'm real sorry about this. So I think my the cord that is supposed to load my mouse has it was probably not fully inserted, but now it seems to be working. Great. Okay, where were we? Okay. Exciting times. So, going from this one to this one, then we have 3, 1. This one is 3. No, it's not. It's actually 3. So this one is 3, 3. And so this one is false. So we don't go into this one. And I think that's good. I don't want... Or we going from this one to this one. So in this case, I don't think I want... But maybe we... Yeah, we do. We want this one to be able to fill this one. But let's see here. This one is 3. And this one is 3. Okay, so this implementation does not work for this case. Just in this case, this one will fill out this one, so that's okay, but I would like this one to be able to fill this one as well. Oh, actually, that's not entirely true. Okay, max fluid surface height is still 4 here, I think. Yes. Okay, so this one goes through less than fluid amount. This one is 0. This one is bigger than that one. So okay, so we get to here. The new fluid amount is 4 minus 3, 1. And the new max is then terrain height 3 plus 1. Okay, so that works. So then if we go from this one to this one, we have 4 and 1. So 1, 4. This one is 2, which is less than 4. And this one is 0, which is less than 1. So we get into this one. So fluid amount here is then max fluids. Okay, this is where I think it's wrong. Max fluid surface height minus terrain height. We get 2 here. And we get 4 here then. But that's not what we want. We want to get 3. So the new calculation fluid amount here should not be based on this one, but rather do we even need this one? We just do this instead. Oh, that's not what I want to do. Ah. Two, 4. Yes. 4. This one never changes, so yeah, we need to change this one. That's what we want to do. And I might have jumped the gun here. Yeah, what we want to do is we still want to calculate this one, and we want to calculate it by I wonder if we want to do it like this. Output fluid amount. But is this how we want to do it? Two, 4. So 2, 4. These passes. Output fluid amount 4 minus 2. So we get 2 again. New max is 4. Yes. And then when we go to here, we have 2 and 4. This one is 4 minus 3, right? So this one is 1 now. Terrain height, and we want to add output fluid amount here. So 1, we get 4. And then when we move here, we have 3. And we have 1, 4. 4 minus 3. That's good. So 1 and 1 output is still 4, but we only add 1. And then finally going from here to here, we have, is it 1 and 4? And that's wrong because we get 2 here. don't want to work with this one here, do I? Now we calculate this one, so terrain height plus, so then we get terrain height plus put fluid amount Now actually I think everything we want to do is terrain height plus input fluid amount is going to be output fluid amount, but we also want to send in, or we also want to do we just want to limit it to this surface height. I think that's everything we want to do. Could do it with a simple if-else, but can we do something with max? Like, I think we can do this. If max fluid surface height, or actually now we're going to do new max fluid surface height, and we're going to do mathf.max between max fluid surface height and this new one. And this is the new max fluid surface height, and I think we should be able to calculate output fluid amount by just doing new max fluid surface height minus terrain height. It shouldn't be harder than this, right? With fluid amount, so in 4.2 we get 4, 4. Okay, and then 2, 4 minus 2, so we get 2. In this case we get, this one is 4, but this one is, yeah, here we go. So this one is actually 5. But then we do max, so this one is still 4. This one is 4 minus terrain height is 3, so output fluid amount is 1. Min, should be min here. So then when we go from here to here, we have 4 and 1. This one is 4. This one becomes 2 plus 1, that's 3. So we take this one because it's the minimum of these two. So this one is 3, and then we get 3 minus 2, we get 1. And on we go. We should never ever get a case where this one can grow from the initial. This one will only decrease and decrease and decrease. This should be it. A little bit worried about this one though. Could we get... It should be okay. And when I think about it, we probably want to truncate the fluid values anyway. Like we want to have... When we recalculate a mesh from the fluid amount and the texture, we don't want to have two neighboring pixels vary in height. They should have the same height. So yeah. Let's do it as a note. Is this how we want to do it? Want to double check so it works as it previously did. Okay, that's beautiful. And if we do minus, we do this, and then we do it's gonna be hard with the current visual tools we have. Probably gonna have to add, yeah, we're gonna add some more functionality. 0.5, is that too much? Oh, is that so? Yes. Yeah, we want to get around that one as well. And now we get... Okay, that's too much. Yeah, let's do this first of all. Subdivision constant 0. So the current fluid solver does not work with patching in the terrain. So now we just do one patch, and I'm actually going to, let's go with this brush. I think we're gonna have a way easier time. And let's go 0.5. Like this, and then we do 0.3. screwed will we get from this one? It's 0.3. Love it. Love it. So, yeah, this one way brighter, this one less bright. Higher water value here, lower here. I think, although, yeah, we need some more visual tools here. And I think we're gonna work with cubes. So for each cell that has water in it, we're gonna spawn a cube. We're gonna set the position of the cube to be equal to the grid position. And then we're gonna scale the cube in the Y direction based on water amount. And offset it based on water amount. But this looks, from an initial, this looks very good. Yeah, fuck it, let's do it. And we're gonna do wonder, can we do we have primitive meshes? I don't want to create extra primitive objects, but let's see here, get primitive mesh unity. Yes. Primitive helper, but that is something they have implemented themselves. Yeah. Okay, let's do it like this then. probably want that one first. Position, size. What bothers me about this one is, yeah, we're gonna do it like this. Terrain data container, raw height, raw fluid amount. And then we do like this. So we take the raw fluid amount, that one is between 0 and 1, and then we lerp based on height range. So height range decides, it's just a remap from 0 and 1 to the actual height range of the terrain. Yeah, Eland, it's probably slower. Like, you need to get over the threshold that is included by the busing of data back and forth from the GPU before you get any speed improvements. Okay, so what we can do here is, in fluid object, we're going to do fluid amount here. This is not going to be the raw fluid amount, but actual fluid amount. Create fluid object, and what we're gonna do here is game object, fluid game object is equal to game object create primitive cube, and we want to name it fluid object we want to use debug log format. Okay, fluid object position.x plus position.z something like that. What? Oh, get the fuck out. Omar Adair, sorry about the pronunciation, but thank you for the follow, appreciate it. And then we want to do return fluid game object. We don't want to return just yet. And then we want to do stuff here. And I wonder... we want to do this and want to do some additional stuff here, but yeah. Local or scale. Transform.local scale size. And here we want to do I'm not so sure that we need to do it here. Or would I? Yeah, maybe. Okay, that's the first step, and then after we have done this, we want to offset the position as well, and we want to offset it as local position plus equals to 0.5 times fluid amount times vector3.up. Right. So in Fluid Solver, the only thing I think we're gonna do this. If oh yeah, we want this one as well. If dot controller is not equal to null, then yeah, we want to do something here, but we want to do, I wonder if I want to get float size is equal to dot yeah, I think we want to do this. And then in Fluid Solver we just do, so when we set the fluid amount here, I think I want to spawn this in Fluid Solver, yes I do. And we're going to do this, and then I noticed this one, we want to change this one, set raw fluid amount. Yes, and then after we have done that, we want to do spawn fluid visualization object, and we want to spawn it at vector 3, and it's going to be x and terrain data dot get dot height x y and then we do y here, and then we have new we want parentheses there, and what's left, it's the fluid amount, and we don't want, fuck, I want to rename these as well. So this is actually raw fluid amount, and we want terrain data dot fluid amount. And that should be it. And now we have pretty much disabled the possibility of adding fluid to a place that already has fluing in a meaningful way, since yeah, the visualization is going to get fucked, but that's okay for now. And the way I did this one, we might as well, I still want to have this one because we're gonna do a lot of changes here. So here I want to do fluid object dot create fluid object position fluid amount. Interesting. Yeah, let's see how it works, how it looks. Yeah, let's hope for the best. Okay, we get a couple of fluid objects, but ooh, we get a lot of them as well. Yeah, that's true. 9, 10, beautiful, but where are they? Yes. Yes. So we want to scale the position by delta, right? And delta is 0.5-ish. Is that enough? Not really. But yeah, then we want to offset them as well. That's true. So the position here, so the position we place these are, the position in X and Z is based on indices, which are whole integers, and yeah, represent an index in a texture. So yeah, we want to convert them to world space. And given only the terrain data, I'm not sure we have an easy way to do this. Fucking hell, would love... It has always been the terrain patch that controls this, and we don't send that one in here. Terrain data. And yeah, we might as well expose it, because if we want to make the fluid simulation be able to traverse terrain patches, we're gonna need terrain patch information here. So yeah, maybe this is the correct time to introduce it. I can imagine it going a little bit back and forth though. I compare the result. I do 5 times 2 both on the GPU and the CPU. What do you do that takes 8 seconds on the CPU? That's a lot of time. They all 100,000 times. Okay, that makes sense. Yeah, just doing a simple number multiplier. Yeah, depends on how you do it the 100,000 times. Are you sending the data down to the GPU 100,000 times as well? Yeah, so what we want to do is, when we create these fluid objects, we want to do something very similar to this one, or actually position. Yeah, we want to get mesh data at index, and we're going to get position. That's what we want to do. And then we do... I thought I had a method for it. What is this? Terrain patch. Although I wonder... Yeah, we have these as well. Yeah, it's gonna hurt a little bit doing what I'm about to do, but I think it's a good choice eventually. So what I want to do is I want to show this one. And then we have height here. That's what we want to do. Oh no. Can we just do... And then I also want to do... I want to add world space here, but yeah. And what we're going to return is mesh data index xy dot position. And fluid solver, I want the initial one here, I want to go and do fluid amount. I think I want to change it so we have terrain patch, but yeah. Terrain patch. And then it's going to be very interesting. I think what we're doing now is we're actually making it work over multiple terrain patches. So definitely want to test this later on. Turns out there's a max thread count for the GPU, yes. I've heard something similar. And that's pretty cool. Yeah, the power of the GPU doing basic things in parallel is insane. Okay, so new terrain, fluid surface height. Here we do terrain patch dot terrain data raw height, and set fluid surface height terrain patch. And that's what we're gonna do. This is nice, I think. We want to do terrain patch affected terrain patch is equal to, oh yeah, we want to do terrain patch dot get terrain patch X and Y. And this might seem weird, but this call here is a very nice utility function. So we check if these are less or bigger than resolution, then we take the neighboring terrain patch. But this is true. This one, if it's true, or like if we don't have a neighbor here, we just take the current one, and that's not what we want to do when it comes to the fluid. So we want to do, I want to implement a get terrain patch unsafe, which returns null. So we're just going to do this. We're going to take this one, terrain patch get terrain patch unsafe. Unsafe might be a strong word, but yeah. And then we're just going to do this one here, and we're just going to return this one, and in this one we're going to do return get terrain patch unsafe X, Y, but if it's equal to null, if it's not equal to null, so then we check if this one is not equal to null, return it, otherwise return this terrain patch. So get terrain patch, this always return a terrain patch, but best case scenario the neighbor, this one can return null. What's up, Sir Novko? What do you write? Generally we're developing a creature collecting game, but specifically today we're working on a fluid solver, so a very basic fluid system that works with a custom terrain. Okay, so get terrain patch unsafe fluid solver. If affected terrain patch is equal to null, return. Fuck, yeah, it's It's a coroutine, so that's not how we can do it, or we can't do it like that. Instead, we're gonna have to do Aland. Yes, yes, I read it, and I said something similar, but that is 100% true. Ooh, what advice would you give for beginners? I have no idea if I'm the right man to giving out advice, and that's a hard question. So I'm guessing that you're talking about beginners in software development, or more specifically game dev. And I don't think I can give anything more than like the very general advice of rely on consistency and make sure you understand the basics. Emphasis on the basics, because those are the foundation. Okay, so this is a coroutine. We can't exit early as I would like to, so I'm afraid that we're gonna have to do if not equal to null, so we just add one more. Oops. Like this. And then what we do is, so now we have an affected terrain patch. And if we have an affected terrain patch, yeah, then we want to check. Yeah, we still want to check if it's within bounds, but now we do it affected terrain patch here. We add it here, here. Although, I think we're gonna do it like this. Terrain data is equal to terrain patch dot terrain data. Can we do it like that? Container. So then we can simplify this one to this, and then we work with terrain data everywhere, but when we send it onward, we want to send in affected terrain patch instead. So eventually what we have done now, or what I think we have done, is we can now, halfway through this fluid simulation, we can actually switch terrain patch. So the water might actually jump from one terrain patch to another. That's beautiful. This is my time messing with compute shaders. Yeah, and you have already like shown the strength of it. It's nice. In what context do you work with, or do you mess around with compute shaders, if I might ask, Aland? Are you sitting in Unity, or is it pure C#, or in what context? Okay, this is beautiful. And now when we spawn fluid visualization object, we don't do this. Instead we do terrain, or affected terrain patch dot position of X and Y. Yeah, let's try this. Let's try this. Compute shaders use HLSL. That depends on... There exists different compute shaders than HLSL, I think. But like, I'm talking more generally, like when you prompt, like, are you working on it in Unity, or like when you prompt? Okay, you're in Unity. Nice. Okay, so you're working with Unity compute shaders. Then I get you, okay, we want to fix these two first of all. Oh yeah. So when we add fluid naive CPU, Terraform brush strength terrain data. So here we want to add this, I think. So seeing this makes me wonder if we eventually... I don't know. We can do it like this for now. Yeah, the fluid is purely on the CPU right now. Yeah. Okay. Okay. I screwed it up. Get terrain. Did I screw it up here? Possibly. Oh yeah, we want to, first of all, we want to check if it's null, definitely. But I don't get how this one... I agree, Ayland, 100%. Things are just so much easier to debug on the CPU side, in my experience. Does this check fail? That's weird. We never get to this one, or do we? Filling. No, we don't. So we quit here or here. Why? Ooh, did I screw up? I don't think so. I'm gonna do one thing also to simplify testing, which I want to fix here. We're gonna, as soon as we change to the brush water, we're gonna minimize the marker. Ooh. Ooh, interesting. Nice. And I'm thinking, yeah, we probably want the fluid simulation to, so when this water tries to spread to this grid, we probably want to include this one, even though the height here is higher than the fluid, because we want this point as our outer mesh, right? Yeah, I think that's true, because if we create water here, we're gonna have a floating mesh. But if we also take the outer one into account, that's gonna be way better. And if we take the outer one into account, like if we take only the outer one into account, we could create meshes that has way less vertices. But I think we want to create this mesh as a grid mesh with a lot of vertices, because we're gonna do some deformations and stuff like that in the water shader later on. So yeah. Okay, but this is beautiful. And what if we do terraform 5 and then we add water of 0.3. Yeah, this is the floating point issues I was talking about, why we want to truncate the water. But this is fucking beautiful. This is great. Look at this. Okay, I want to try see if it works if we have patches and we create water at a patch junction. So I think these thick lines should be visualize the different patches. Yeah, that's great. So then if we do this, do this, and we add water, I don't know, 0.4 maybe. Okay, something is broken. But we get to an end result. The question is, yeah, we create our water object over here, and I think I know why. Yes, I do. The position we get in world space are actually not world space, but rather local space for the patch itself. Yes. But oh, this is a nice body of water. But I'm still not fully convinced that it was generated accordingly, but we're gonna fix the first issue and worry about the rest. So I'm thinking of doing terrain patch. I'm gonna introduce some shader styles here. Ayland, I think compute shaders can import other compute shaders. Yeah, I think they should, but if it's something like traditional shaders in HLSL, it's basically just you do an import, and the compiler basically takes whatever is in that imported file and puts it in that shader, as I've understood it. So we're gonna do position object space, and we're gonna have public vector3 position world space. Int x, int y, and here we're gonna do something plus position object space, and in this case it's going to be, what is it, transform.position, I think. Oh yeah. And then if we jump to our fluid solver now, we want to take position world space here. Let's see if that's better. Ooh. Not entirely correct. We never switch. Let's see here. Yeah, we want to be a little bit more careful when we add these as well, I think. Okay, we never add for the other terrain patch. Interesting. With colliders as well. Yeah, we might want to skip colliders. Love it. So why doesn't it go to the next collider? And we're gonna double check that. I just need to run AFK real quick. So be right back real quick. Okay, back. ChatGPT says in Unity importing or using multiple compute shaders within one compute shader file isn't directly supported. Find that weird. Okay, so why don't we move to the next patch? That is the question. And I want to remove, definitely want to remove the colliders here. So let's do that real quick first. Then I guess we want to do destroy. Okay, so fluid solver. What happens here? We get a terrain data, affected terrain patch, terrain data. No. We get an affected terrain patch, and if it's not equal to null, we continue. I don't see why this wouldn't work. But yes. Yeah, we want to be a bit more Yeah, okay, it fails here. So we do get a neighboring terrain patch, but we don't flip our coordinates. And what we could do is that we could rely on get index wrapped x, get index wrapped y. Yeah, fuck, we want to do that, I think. So we do this. And I want to do input x, input y. And then we want to do int x is equal to terrain patch get index wrapped x, input x, and int y terrain patch dot get index wrapped y. So let's say we have a resolution of 100. This one is 101. We get the neighboring terrain patch and then we wrap the indices around. So 101 becomes 1. And 100 actually becomes 0. And then we use these, the wrapped indices, when we continue onwards here. Although yeah, I think that's good. And I've also said that this fluid simulation should run on a thread, a separate thread. Calculate the next stable state, and then we recreate meshes out of that and visually render it. But there's also the question, like this one is in the future, or for the future, but it wouldn't hurt to start thinking about it, and that is how we want the water to look when it appears in game. So to visually change it in each iteration is one approach. Then you get some sort of flowing water. Or so you could base it partly on this, or we could try and do it all with shader magic. So that we generate this, we generate the full stable state, convert it into a mesh, and then in some way in the shader magic, in the shader, we make it appear in a nice way. But that's going to be harder. You could also think about a case where you use this data and you paint a texture with this data. Like when did what pixel get filled with water and so on, and then you have some sort of dispersion texture which you can use in the water shader. Yeah, it's gonna be a problem to solve, but an interesting one. Alan, I want to learn Compute Shader because I have a script that make a line renderer with get bigger further away from the camera, and I want to port that into Compute Shader. That sounds like just like a rendering problem, doesn't it? Like you want the line width of the line renderer to get bigger the further away from the camera you are. And like Depends on semantics, I guess, but a plain old shader would do, I think. Okay, so I want to try this. Beautiful. Okay, that's fucking great. And we no longer have any colliders on these. And now we have a fluid simulation that traverses terrain patches. So we have somewhat fluid on this side and some of this side. The problem with this one, nice indeed. The problem with this one, which we're gonna have to handle when we create the mesh, is that we get overlapping points here. But that's based on how the actual terrain is structured. But that is, like, this works as we would have hoped. And this is just a problem we're gonna have to handle when we convert it to a mesh. And that's because, like, each terrain or neighboring terrain patches actually represent the same data twice. Did I paint it right there? Let's see here. So the points here, they fetch their values from one texture, and the points here fetch their value from another texture, but these pixels are actually the same for these two textures. It's a nice solution to making terrain patches sync, but not having to worry that much about it when we actually do terraforming. Ayland, I tried shader, but it just got really glitching when the texture go over 1 for some reason. When the size texture go over 1. Yeah, when you work with textures in shaders, you usually work with UV coordinates, right? And they are always between 0 and 1, if that has something to do with it. Okay, this is very nice, I would say. One of these days I need to do a perform profiler on this, because I think we have some form of garbage collector steps that are giving some spikes now and then. But okay, do I want to bring it to its span? Yeah, let's try it. So if we do terraform like this, and this, and this, and this maybe, and then we add, I want to be careful here that I don't add too much water, but 0.3 maybe, or 0.4. I fucking love what I'm seeing here. Not this one particularly. I'm very worried about this one though. But I might know. Possibly. Or actually... Yeah, we might want to adjust the algorithm a tiny bit. It's not too bad. What is with the weird frame drops though? Is it because of the number of objects? Or are we still getting... Okay, was it just... The FPS is a little bit weird. Damn, that's a lot of water objects. Is it actually that many? Okay, we get double. Oh yeah, we get double. Okay, I get that. Yeah, we haven't. There's a lot of things to do. Beautiful. I can already see this after a shader revamp. Yeah, I think it is gonna look real good. So a pool of water here. We have some flowing water here. A pool of water here. But yeah. We have some small problems here we want to take care of. What's up, Smack? Good morning, good morning. So yeah, we have one. So for instance, we can see, I think if we take this one, I think we have multiple objects here. Yes, we do. And that's because initially... yeah, initially we got this much water. And then we got more water, so we spawned a new object. But then, I wonder if we got a little bit more water and spawned a new object. I don't know. Let's see, what do we have? We have 3 objects here with the same height. That's not too good. And this flow here makes it I'm mostly okay with how this looks, so that this one would spill over going down here downwards, but still, yeah, we want water to disperse. Will dispersion fix? So this one should send on a little bit less, a little bit less, a little bit less. But this one is a problem, definitely. Because the thing here is that this one gives this much amount to this one, but the terrain is so much lower here that we get this like a hole, basically. It's not too bad as a first iteration, definitely not. The FPS is crazy low though. Yeah, it's these problems. Definitely want to fix. Apart from this one. Actually, yeah. It's this one. Apart from this one. Like this would look beautiful. You have one big pool of water here. You have another big pool of water here, but you have a little bit of a height difference here. Animated with some kind of flow in the water shader. And here you have a lot of height difference, so you have a bigger flow, but you also have a local minimum here that is weird. But I tried normal shader again, but still glitching. Feel free to post it in the Discord. Very interested in to see how it's glitching. What the fuck? How can we change in the fluid solver to... If we disperse based on distance traveled, we will get way lower water here, because what makes this one stand out is that you have higher surface all around it. Disperse water amount, yeah, maybe. Maybe. And when I'm thinking about it, we might not need to truncate these. It might be nice to have it might be nice to have some... Yeah, but this one, biggest problem, hands down. And if we disperse here... wonder. Yeah, what it basically comes down to, when we go over the edge here, so we have a lot of water, and when we get to the edge we get a small amount of water. Yeah, I do want to introduce dispersion of water. That is going to solve the issue if we add water here as well. Yeah, depending on how we implement it, of course. I love this. I love this. Except for this part then. With some shader magic, flow, more flow. I think it's gonna look beautiful. We could also introduce, so when we flow out from this one, for instance, we only flow in the direction where the gradient is the biggest. So we only flow to this one. And yeah, that works if we have a height difference. Yeah, we can do a lot of interesting stuff here. I wonder how I want to do it. I'm thinking of okay, so this one, the implementation we have right now, set fluid surface height. We want to rename this a little bit. So I'm thinking of marking this one as complete. Like this is the most naive one, which does allow for us draining the entire terrain in water. So if we add an amount on a just pure plane, this one will run until every pixel has water on it. And I think that's okay for this one. And this is going to be the first one, looks like, so very naive, CPU based. And then we're going to add another one with more rules, and then we're going to add another one with more rules, and so on. I think that's what we're going to do. I try messaging with you with the texture just to select world position now. Not. I don't think I fully follow. But before we continue with the fluid solver, I just need to run AFK real quick. Just grab something to eat real quick. So be right back, a couple of minutes. Around 5, I would say. Okay, back. Sorry about that. So, okay, first of all, I want to do one thing, and that is I want to reset the size of this one as soon as we change to water here. So when we add water, we're just gonna do it on 1 point. So it's just going to be a little bit easier to debug. And then I'm going to clean up the current fluid solver and commit it, and then we can start working on the second iteration of it. So let's see here, action Terraform. Is it actually Terraform a brush? Set brush texture index, change brush texture index. So change brush mode. Yes. So I want to jump to Terraform brush mode, and we have water change. And I'm gonna add int Or bool reset. Oh no, do we actually brush strength? Oh, that's true. Okay, so that's not here. Nice, Ayland. I will look at it after the stream. Terraform brush. Why the hell? Okay, so that's the first thing we're gonna do. Action terraform. We want terraform point radius. Yeah, we want this one. To be included in the brush. Definitely. So update terraform point radius. What do we do? Terraform visual point scale clamp. Yo, what's up, Fabic? Good morning. Yeah, we pretty much just want to pack this one into our terraform brush. Should have done that a long time ago. And yo, what's up, Derek? Just popped in and looked at what you have for the water so far. Nice work. Thank you, appreciate it. Yeah, it's moving forward. Slightly and slowly, but forward. Yeah, I know, Fabic. But this week, I think we're gonna go for a little bit of a longer streams. And they are going to be way less stressful. As to the progress today, I think it has been very, very good. Okay, so before we do these changes, let's just show a tiny bit. So this is the very naive water approach. Although I wonder what my spikes are coming from. So if we do this and this and this, maybe I can do something like this. And then we add water here. I have to be careful so I don't add too much water, but 0.4 should be okay. That's almost a little bit too little, or is it? So we get a big pool of water, we get some nice flow going on, but we have these local minimas. So these are the biggest problem with this naive approach. These local minimas here. But I think we can get around them. Yo, what's up, Norin Dev? I'm just working away, grinding away on this water shader. Not shader, but water system. So these local minimas, the biggest drawback, and then I I still wonder what's with the spikes we get sometimes, but yeah, let's not worry about those too much. Yeah, so that's what we have right now. But right now we're just gonna make a yeah, I mean, this is still looks good. We're gonna make some nice changes to the Terraform brush to make it easier to work with, some constraints to it, and then I'm going to commit the current implementation of the fluid system, and then we can start working on the more detailed one. I'm wondering about these spikes though. They suck. But it's 100% a garbage collector. Or is it? Editor loop. Editor loop. Editor. Why is the editor loop giving me these spikes? I wonder. So right now, if we terraform, the water does not adjust. It does not. Yeah, it's probably editor garbage collector, but I have to look into it, but that's not what we're gonna do now. So if we terraform, we get this. But I think it will be pretty easy to solve. I think. Possibly. Yeah. So that's definitely something we need to do. Handle yeah, let's just leave it like that for now. I saw the same in my game, but when I play build, I don't see any spikes. Oh, that's nice. Yeah, like I'm gonna have to go in a little bit deeper on the profiler, but when we can, like, clearly seeing that it's the editor loop that creates the spikes, makes me feel a little bit better about it. But like, it might still be some. I could still possibly affect it if we just improve certain aspects of the game. Yeah, exactly. We're gonna leave. We're not gonna worry about the editor loop for now. But I just hate playing around with spikes. It sucks. Okay, but back to this one. So action terraform. We're gonna move anything that has with the brush radius. We're gonna move to the brush. So terraform brush. Brush settings. Yeah, we want to diversify this a bit, or group it, I guess. Brush material, related settings. And then we're gonna have brush operation. That's going to be brush operation, and I want to have brush strength delta change, brush strength. We want to move this one up to this one, I think. Brush strength, we're gonna do brush properties, maybe. Brush strength delta change, brush strength, and we're gonna add a, can we do space? And here we're gonna have a serialized field. Float brush radius delta change. We're gonna have a public float brush radius get private set, and we're gonna have a serialized field private range brush radius range. Enjoy that breakfast and appreciate the lurk mode, Fabic. Okay, and then I want to add, yeah, we're gonna do brush strength. And we're gonna do brush radius is equal to brush radius range dot clamp, and the value here is going to be brush radius plus sign multiplied by brush radius delta change. I think this is how we want to do it for now. So action terraform, what do we have here? We have visual point scale range and terraform visual point scale change multiplier. Terraform brush, and here we have terraform visual point scale range 0.1 and 100. Yeah, I guess it's 0.1 and 100. And delta change. Don't we have private flow, terraform, visual point, scale change, multiplier? Where do we get that one from? Terrain delta, beautiful. Yeah, that makes sense. So brush radius delta change. We just want to change this one to a private. And then I think we're just gonna have a this, so we're gonna move it to terraform brush, set error margin. I think we still want this one here though. But let's see here. So let's try and remove change multiplier and whoa. Do we 0.5 again? It's actually scale delta. Okay, so we want to do sine. That's okay. Scale delta. So here we do like that. Do we have any? I want to keep error margin within the brush as well, I think. Do we have this one hard-coded or? We do terrain delta, okay. Yeah, so let's do terraform brush. We're gonna do brush radius. We're gonna make this private. I think. And then we're gonna have brush radius range. Yeah. Brush radius, private float, brush radius, error margin. And I'm gonna do texture. Can I have this one with a big B? Is this? Not recommended to name it like this. Maybe it is. I know usually one would go this, but I'm not sure. Width error margin. Brush radius plus brush radius error margin. We have set brush radius, delta change. We're gonna have set brush error margin. And then I actually want to have a function like this. Set, yeah. Did I screw this up? Let's see here. Scalar event. I wanna check. Terraform point, this one we still need. Terraform point radius, joink, terraform point height. Let's leave that one for now. So, two times terraform point radius plus margin. Like this, a bit cleaner, and then we can do terrain patches, overlap box, terraform point. Are all of these same? Ah, we have height here though. Fuck it, let's add height as well. I want to add this one as well. Does it make sense? Yeah, it does make sense. But I would probably like to add these as well then. Like, so let Terraform brush be both the underlying data and the visuals of it. Yeah, I think so. Let's begin with this one, see if we can make it work. Height. So terrain height range delta, yeah. Terraform point height. Yeah. So we can do Terraform point height. Brush properties, brush radius, error margin, on and on it goes. Private float, brush height. And then we do so this one, what I want to do here is brush extends. So brush radius with error margin. And Terraform point height, brush height, might as well. Something like that. Would it be too long to have it on one line? Probably. But we might as well do it like this. So in Action Terraform, when we do overlap box here, we might as well just do And we're gonna clean this up some additional, even more later on, but here we want to do Terraform brush dot extends, brush extends. Get the Terraform data, Terraform point radius, Terraform brush dot brush radius. Brush. Yeah, we might want to skip that one eventually. Then we get Terraform data, Terraform point, and radius again. Ooh, is it half extents? Yeah, and in this case, I wonder if we can just do it like this. A little bit cleaner. Okay, I wonder how much I've broken things now. So what do we have? Character, Terraform brush, texture settings, brush material, brush range, brush strength. Yeah, I think we're moving it to one step too much. So it's when we set delta change, we just want to do terrain delta, I guess, but yeah. Way better. Nice. Okay. Next on, I think I want to move this one as well. Terrain delta, do we need this one after the initial update terraform point? Oh yeah, we do. The bug marker, I'm not entirely sure. I still want to, I might want to keep that one still. These ones might be better off we just fix it in the material itself. Yeah, definitely. There's really no need. The only thing these are used for is to set the material or the shader property. We might as well do that in the material. Yeah, we're gonna clean this up a bit. I like that Action Terraform. We remove functionality from this one, move it to another class. So this one will pretty much be the layer. It's an action, it's a character action, but its purpose is pretty much to since it's an action, it keeps track of its own state in the state machine, that is actions. But then it's also a communicator between input and doing the actual terraforming. So things like Terraform Point and the other stuff we have moved into Terraform Brush, those are more, it's up to the Terraform Brush to keep track of those, but it's Action Terraform's job to pass on this information based on input. So yeah, I think it's the better option. Zilzoze, thank you for the follow, appreciate it. So next task when it comes to cleaning this one up is to move this one into the Terraform Brush. Terraform Brush, and what do we have? Texture settings, brush material, brush properties. Do the spaces screw it up for me here? Oh, we don't need a space here. I'm wondering, I'm thinking of doing it like this. Brush properties. And this prefix here, which is basically used everywhere, I think we can skip that one eventually as well. Because we have brush in the class name here. Remove the prefix for variables or properties. Okay, but we're gonna keep it now. So brush position, and then we're gonna create a nice function that is set brush position. New position. And for now, we're just gonna do new position. Oh yeah. And then we do terraform point. This truncation here. Yeah, fuck, we probably, yeah. So we use this one instead, and then when we mimic this one for now, we're gonna do do I want to keep that one? Yeah, we're gonna clean this up a lot. So for instance, yeah, we're gonna create one private. I'm probably gonna underscore it before, and then it's going to have a public get, and instead of a method set, we're gonna have a property setter. Yeah, I think that's way better. But for now, let's run with this. Brush position, overlap box. Yeah, we're gonna do this. A line render also offsetting the texture. Is it apparent in the images and texts you sent on the Discord? Yeah, so here we're gonna do get terraform data. I'm gonna change this one, I think. TP Terraform brush dot do we have brush here? Oh, we're actually in terrain. Get Terraform data. Yeah, we're gonna change this one. We're gonna do Terraform brush. And this is what I hate, because now it's going to be brush dot brush position. So brush dot brush position. We want to get rid of that in the future. And then we do brush dot brush radius. So get Terraform data here. Terraform brush. Generate Terraform data. Given Terraform brush, where Terraform data is within bounds, make it into a list. And then we move on. Terrain patch. Ooh, is this something left over from... Yes, it is. Yeah, okay, so this is extremely unoptimized. This is debug related code. We get the Terraform data. Fuck it. Oh, did I say yesterday? I mean, this is leftover code from way back. Way back. Here we do overlap box, Terraform point, Terraform brush half extents. Instead we just do Terraform brush dot get overlapping colliders. And here we create terrain batch terraformers, and we send in Terraform brush and point. We only send in this one. Is that it? Yeah, busted indeed. I promise, hand on heart, I didn't do a shadow stream yesterday. Alan, what is tangent space in Shady Graph? Tangent space is much like object space or world space, but tangent space is defined by the tangents, or the vertex normal, tangent, and binormal. So it's pretty much a 3D space defined by a vertex tangents most often. For instance, normal maps or bump maps are usually in tangent space. So if you want to get a normal from a normal map, you need to transform it. Like you want the normal in world space, then you need to do a transform from tangent space to world space. Let's see if I broke the marker or if it still works. Visually it still works. functionally as well, I think. Have I increased the density of the grass? It looks a little bit too dense, but well, it's probably just the changes we made to it. Okay, but that seems to still work. So, one additional last cleanup I want to do is related to this one. I want to pack that into Terraform Brush as well. Terraform Brush, there's a lot of things here now. I'm not... yeah, whatever. Brush visuals. And let's see, we also need to keep track of Terraform Visual Grid Alpha, these three, right? This one, and this one. So marker sphere alpha of this one. It's this one. And these two, right? So let's see here. UI materials. Alpha fall of begin distance. Is it this one? Yeah, 1. Grid line width. 0.1. And grid point radius. Also 0.1. Unless... no, we never changed these. Oh, unless... yeah, grid line width, so 1, 0.01, 0.025. So that means that we can remove these three, this one, and this one. We don't need to set them here because they're already set in the material. Okay, so that's those. What more do we have here? Terrain delta, terrain delta. Transform, visual point material. Here we set terrain delta and we set terrain offset, I think. Yeah, we still want sphere center. Okay. Terraform brush, I'm gonna add some additional, but let's see here. Visual brush center shader property and visual brush radius shader property name. And this is what I think we're gonna clean, like the biggest cleanup. And so every time we update terraform point or update terraform point radius, we call this one and this one, and then we also do this. But now we're just gonna do it inside of the brush instead. So this one, scale is only called once. This one is also only called once. But what do? We do terraform visual point. Okay, we still want that one, that is true. So, terraform visual point, create primitive. Terraform brush. Instantiate, do we call this one? Yeah, we do. Terraform brush instantiate. And here we're gonna do brush visuals, private game object. Oh yeah. Let's just do that, and then we have the material here. Yeah, we still use that one. I think we can pack this into the Terraform brush as well. Okay. So these we need to set. Terraform. And then we need these two, and we'll rename them to this one. That's not entirely true. And then we have this one as well. Just do delta and offset. Update Terraform point. Yeah, I still want to do these calculations out here, I think. But yeah, this one we want to do in set brush position. So here we do brush visual object transform position is equal to And then visual point material. Okay, so that's this one. And then we have this one as well. And finally, this one. Okay, so moved a lot of the logic from Action Terraform to Terraform Brush. I think that's a good decision. So let's see if it still holds. Okay, we get a lot of errors. Yes, because the material in question was never set. So brush visual material none. I want it to crash if we don't set this one. Terrain mark, material terrain marker. Yeah. Yes, okay. So now, yeah, this one should be way cleaner. We still have this one, which we don't really use anymore, but yeah. Would love to be able to put this in the brush as well, but maybe. Okay, so what I want to do now is if we jump from any mode to we're gonna do like I want to be able to reset the scale based on mode change. Resets. Resets. I'm just thinking how specific I want this one to be. Like resets radius. Let's be specific. Default, return false, and case water change return true. And then we also have offset. Let's add one that is default F, and then we have case water change default strength. We want to fix those as well. Default strength 0.1. What's up, cinnamon roll? Resets radius, public static bool resets strength. Switch. Oops. Resets strength, resets radius. So then we have default strength and default radius. I have no idea what I want to put here. And I want to add one more thing soon. Yeah, we're gonna have Ooh, I don't know how we want to solve this. Cinnamon Roll, do you think Unreal Engine is better than Unity? It's all relative, you know. Better in what way? Like, for instance, usability or ease of use, I would say no. But it's a hard question to answer. What I would like to have here as well is I would like to be able to clamp radius based on mode. So resets radius, resets strength, default radius. And then we can do, I think I'm gonna do it like this. Public, static, float, get, let's worry about this one in a second. Let's use the ones we have so far. Yeah, the size answer is perfect. If you have an internship project in which you need to recreate a game, see, like I think Unity is way easier to use. So for that purpose, I would go with Unity. Okay, so what I want to do here is we have resets radius, resets strength. So when we change, when the brush changes mode, so change brush mode, is that all we have? Mode. Yes, so when we do change brush mode, I want to set the new mode. We want to do this one, and I also want to do if mode resets radius, do something, set brush radius, whoa. Okay, so when we do set brush radius, when we calculate this one, so this, we can make this so much cleaner, but we're gonna put this one here for now. As well. So when we do reset radius, we want to do set brush radius, and what we want to set it to is mode default radius. And then we also want to check if mode dot resets strength. Then we want to do set brush so we have change brush strength. still want to clamp it, that's true. Then we need to do this. Yeah, we're gonna do this, and when we calculate this one, we're going to do or that, and then we do set brush strength here, and we do mode dot default strength. Cinnamon roll, since how long have you been game dev? 2016, I think. Okay, I want to do one more thing here. When we do change brush radius, we do it brush radius range clamp here. I want to do a function that is public static float, or not float, but range, and it's going to be bounds mode, and then we're going to send in one additional thing here. We're going to do primary range primary bounds, and we're going to return actually switch default return primary bounds. And then in the case of Terraform brush mode water change, we're going to return new range min max, and we're going to do mathf dot max of 0.1, hard-coded right now. Yeah, primary bounds dot min. Yeah, so we want to take the max value of this, that is going to be our new lower bound, and then I want to take mathf min of 0.1 and primary bounds dot max. So for water change, we will depending on these, of course, we will get a range that has 0.1, 0.1, and this basically locks us, so we can't change the size of the brush when we're in water mode, or that's what I'm hoping to achieve. So when we change brush radius or set brush radius, we need to do mode dot bounce and then we send in this one and then we clamp. So we get the bounce based on mode and then we clamp the radius based on that. Set brush radius. Change brush radius. Something like that. So if I change to grass, nothing happens. If I change to water, we go down to 1, and I can't change the radius. Okay, I think that's good. Very nice. Do we change? Yeah, we changed the default value as well. That's good. Okay, we can add more water, but we're getting a lot of duplicated debug squares, but that's okay. This is another case we need to think about how to handle. Adding a lot of water here flows down to here, but we always have a higher point here. Yeah, we want to add some like dispersion constant based on yeah, we're gonna have to think about that one. Okay, we're gonna continue. I just need to run AFK real quick again. Okay, back, sorry about that. So let's see here. I wanna commit the fluid solver changes as well. I think this one is in a pretty good state as for being naive enough. Wondering. I'm wondering how yeah, we're probably gonna do, let's see here. Every entry point to the fluid solver, independent on what type they are, is going to look like this, I think. And when it comes to the fluid objects, I probably want to store them in some sort of array. So when we fill up the water, we remove the previous one. I think we're going to utilize them enough for it being worth it. But let's start by adding a fluid solver mode. Naive CPU, and then we add a add fluid, mode. And then we do a switch case here. And default might just be return. Case. We need a break. Always going to be the entry point. This one decides the algorithm we're going to use. I want to move these away from here as well, I think. Alter terrain data, if water change, fuck, do I wanna? Maybe we can just do it like this. And now the big question is how I want to solve these. I think I still want to keep it inside of the fluid solver. I don't want to dirty down the terrain patch with this information. It's mostly, it's going to be debug related all the time. So I'm thinking of doing something like fluid objects, and then we're gonna change this one, spawn fluid visualization object. If fluid objects does not contain key, then we want to do add terrain patch and new game object terrain patch dot resolution terrain patch dot resolution. Good. And then we can do if fluid objects dot, I guess we can do this, terrain patch x y is not equal to null. Actually get actually, why can't we do oh yeah, that's how we want to do it. Okay. If it's not equal to null, we can't call this. Oh, we can. Destroy. So if we already have a fluid object at that position for that terrain patch, we delete it. And then when we get down to here, we need to calculate a position, which is just equal to terrain patch dot position in world space x y, and fluid amount is just fluid amount. But we don't want to set this one free. We want to do fluid objects terrain patch x y is equal to this one. Ooh. And let's just keep it like this. It's debug related. And then, oh, terrain data. That's how we want to do it. So fluid amount here should be, yeah, we don't care about fluid amount. Is equal to and then we create the object and add it to the dictionary. Okay, let's see if this still works with the current setup. I don't need to scale that one anymore. Yeah, we have one problem. Fluid solver, none. We want to do naive CPU. Great. How many objects do we have? Okay, so now the question is, if I add fluid... two. I don't think we're destroying any. No, we're not. Yes. That's what we want to do. That's rough. I don't know. Yeah, I think we're destroying them at least. Okay, but now, unfortunately, I gotta run. But I will continue this tomorrow, hopefully making this one a bit more smart. But yes, as always, thank you so much for watching, everybody, and have a great rest of the day. Peace.